This video is on complex numbers. Start off with the imaginary unit I. I comes from the square root of -1. Cannot take the square root of negative 1, so we will use I to represent the square root of -1. So just going and looking at simplifying radicals. If we just had the square root of 25, the square root of 25 is 5, because 5 times 5 is 25. Whenever you're taking the square root of a number, you have to ask yourself what times itself twice will give you that number that's under the radical. So we look at square root of 81, that's 9. Square root of 121 is 11. Square root of 64 is 8. And that's because 8 times 8 is 64. So when we look at the square root of negative, there's no such thing as two numbers times itself that will give you a negative value. So if I look at the square root of -25, if I look at breaking this up, I can break it up into what I cannot take the square root of and what I can take the square root of. The square root of -1 cannot be taken the square root of, and the square root cannot be taken the square root of evenly. But I can take the square root of 25. So square root of -1 is I, square root of 25 is 5, and so that'll be 5I. So that's the breakdown of what actually happens. Of course, you don't have to go through that whole process. Just recognize that if you have a negative under your square root, then you will always have an I to represent it in its simplest form. So the square root of -81 is 9I. Square root of -121 is 11I. Square root of -64 is 8I. Also, don't forget the times when you cannot take the square root of something evenly, but you can break it down further by taking the square root of some of its factors, or the square root of one of its factors. So the square root of 18, I can break that 18 up into 9 times 2, because 9 is the perfect square. Breaking 18 up into 6 times 3 does not help, because you cannot take the square root of 6 or 3. So you want to break the number down into one of the factors, or allowing one of the factors to be able to be taken the square root of. So we're using 9 times 2. Square root of 9 is 3, and we leave the 2 under the radical. So the same thing happens to the square root of -24. I would break it up into the square root of -4 times the square root of 6. The square root of -4, I know I can reduce that down to 2I, and I will leave the 6 under the radical. Square root of -500, I will break it up into the square root of -100 times square root of 5. The square root of -100 is 10I, leave the 5 under the radical. Also, if I had the square root of the negative of a prime number, something that cannot be reduced, or something that cannot be reduced by taking the square root of one of its factors. Let's say if I had the square root of -17, all I would do is bring the I out front. That would be I square root of 17. Or you can write the I in the back. You just have to be careful and make sure that you don't extend the radical over the I, which will give you a different value altogether. Same thing over here. When I have 2I square root of 6, I can put the I in the back, and it would be 2 square root of 6I. Just have to make sure that the radical does not extend over the I as well. So when we have complex numbers, what's going to happen is we're going to have a real part and an imaginary part. In your standard form, we'll have the real part first, imaginary part second. So examples of that would be 5 minus 11I, or 7 plus 4I, having a real part and an imaginary part. So if we want to add or subtract complex numbers, it's the same thing as combining your like terms. We have 5 minus 11I, 7 plus 4I. Add the 5 and the 7, which would be 12, -11I, and the 4I will be -7I. So that's 12 minus 7I. Once again, notice it's in standard form because we put the real part first, imaginary part second. Next one, if we want to subtract, we have -5 plus I minus the quantity of -11 minus 6I. Just like when you're subtracting your algebraic expressions, you distribute the negative into the quantity that follows. So that negative turns into a positive 11 and a positive 6I. Combining your like terms, that's -5 plus 11, which is 6. I plus 6I, 7I. Multiplying complex numbers, here we distribute 4I into the quantity of 3 minus 5I. So 4I plus 3 is 12I. 4I times -5I is -20I squared. So don't forget to multiply the i's together. It's 20I squared. So we have to be careful. I squared can never be left in your answer as in its most simplest form, or to be considered its most simplest form, because I squared, when you reduce it, will give you -1. So whenever you have I squared, that's going to be -1. So here, that's 20, -20 times -1, which is a +20. That ends up being your real part. So make sure you put the real part first, imaginary part second. Here, 7 minus 3i times -2 minus 5i. Do your binomial distribution. 7 times -2 is -14. 7 times -5i is -35i. -3i times -6 is +6i. -3i times -5i, +15i squared. Combine your like terms in the middle. -35i plus 6i is -29i. I squared turns to negative, so that's a -15 and a -14, which would be -29 minus 29i. One more binomial distribution. 5 plus 7i times 5 minus 7i. 5 times 5 is 25. 5 times -7i is -35i. 7i times 5i is 35i. And then 7i times -7i is -49i squared. 35 i's in the middle will cancel. I squared turns to -1. -49 times -1 is a +49. Add those together, that'll give you 74. All right, complex conjugates. A plus bi and A minus bi are complex conjugates of each other. Whenever you have the same real number, and the only thing that's different is the middle sign. In other words, the sign of your imaginary number. They will be your complex conjugates. They'll be conjugates. So 5 plus 2i and 5 minus 2i are complex conjugates of each other. -3 and -3 minus I, -3 plus I, and even 7i and -7i. Remember, all we have to do is change the sign of your imaginary number or your imaginary part. Then that will be your conjugate, your complex conjugate. Also take note from the last or the previous example. When complex conjugates are multiplied, the imaginary part cancels out. So going back here, 5 plus 7i, 5 minus 7i, when we multiply to get them together, the imaginary part cancels, leaving us with just 74. That will always occur whenever you multiply your complex conjugates. Okay, so dividing complex numbers. If we have 3i over 4 plus I, we want to divide it, or what we call dividing when dealing with complex numbers. We're going to multiply the top and bottom by the complex conjugate of your denominator, or the bottom. So in other words, we're going to multiply top and bottom by 4 minus I. So if you do 4 plus I, 4 minus I, binomial distribution, 4 times 4 is 16. 4 times negative I is -4i. I times 4 is 4i. I times negative I is negative I squared. 4 i's in the middle are going to cancel. Remember that it's supposed to occur if you're dealing with complex conjugates. When you multiply them, the I part or the imaginary part will cancel. I squared turns into -1. So you have 16 minus -1, which is 17. That's our denominator. That's our bottom number. Up top, 3i times 4 minus I. 3i times 4 is 12i. 3i times -I is -3i squared. I squared turns to -1, so that's a +3 plus 12i. And also, when it comes to standard form and you're dealing with fractions, you do have to separate it. They expect you to separate your numbers, so you cannot just leave it as 3 plus 12i over 17. Normally, they want you to separate it and write 3 over 17 plus 12i over 17 as your final answer. All right, last few examples. Simplifying properly. You want to make sure you're okay with simplifying these radicals. The incorrect way of doing this, if we have the square root of -25 times the square root of -4, normally we would just multiply what's on the radicals together and get our answer, simplify as much as we can to get our answer. But whenever we're dealing with negatives under our radicals, we cannot do that. Notice here we get a +10. Actually, what you need to do is bring out the I first. You reduce the imaginary part first. If you have a negative under your radical, bring out the I first before you multiply the terms. So that'll be I square root of 25 times I square root of 4. Then if you can reduce before you multiply, feel free to do so. That's 5i times 2i. I messed up on my 2 right here, so that is 2i. 5i times 2i, which will give you 10i squared. I squared is -1. So your final answer, or your most simplified answer, would be -10. So notice in the first way we did it, which was the incorrect way, we had +10. In the correct way, you would get a -10 as your final answer. So here we have negative or square root of negative 18 minus square root of negative 8. So the first thing we do is reduce both of these down. We couldn't subtract these in the current form even if we wanted to, because whenever you have something like this, the radicand and the index to your radical has to be the same. The radicand is what's under your radical. So notice we have negative 18 and negative 8 under our radical. Since they aren't the same, we would not be able to combine them, so we do need to reduce. So we take the square root of negative 18, break it up into negative 9 times 2. Square root of negative 9 is 3i, and we use 2 under the radical. Take the square root of negative 8, do the same thing, break it up into negative 4 times 2. The square root of negative 4 is 2i, and you leave the 2 under the radical. So taking those back to the problem is 3i square root of 2 minus 2i square root of 2. So because we have the imaginary in both cases, we have the same index to the radical in both cases, and we have the radicand, what's under the radical, the same in both cases. That means we can reduce and subtract the term. So 3i square root of 2 minus 2i square root of 2 is 1i square root of 2. Here we have negative 1 plus the square root of negative 5 squared. So don't forget, whenever you have a quantity being squared, you have to expand that out and write negative 1 plus I square root of 5 times negative 1 plus I square root of 5. We went ahead and took out the I. Remember, if you're going to multiply them out, you have to bring the I out first. So negative 1 times negative 1 is positive 1. Negative 1 times I square root of 5 is negative I square root of 5. I square root of 5 times negative 1, negative I square root of 5. I square root of 5 times I square root of 5 is I squared square root of 25. So you multiply the i's together, which is I squared. Square root of 5 times square root of 5 is square root of 25. Combine your like terms, that'll give you negative 2i square root of 5. I squared is negative 1. Square root of 25 is 5, so that'll be a negative 5. Then 1 minus 5 is negative 4. So it's negative 4 minus 2i square root of 5. Last one, square root of 25 plus, negative 25, plus square root of negative 50 over 15. So we will reduce the square root of negative 50, break it up into the square root of negative 25 times 2. Square root of negative 25 is 5i, leave the 2 under the radical. So that's where we simplify that 2. Then that 15 needs to go into each term. So there's negative 25 over 15 plus 5i square root of 2 over 15. We'll reduce that down by 5 in both cases. So it'll be negative 5 over 3 plus I square root of 2 over 3 as a final answer. Let me know if you have any questions.